Okay. To calculate the total shear strength or effective shear strength, we need these shear strength parameters C and phi, C prime and phi prime, and we can get them only from the triaxial shear strength test, triaxial shear test. And let us say we have conducted triaxial shear test on one sample and got sigma 3 prime as sigma 3 minus u and sigma 1 prime as sigma 1 minus u. We can get C prime and phi prime to calculate the effective shear strength tau f prime. Prime is missing there for any value of sigma prime, which is sigma minus u, provided we know this theta to calculate 2 theta and draw this radius from center to draw this perpendicular Mohr Coulomb failure envelope. But we cannot really get theta from the sample because when we do this test, we will not be able to measure the failure plane angle. Most of the times the failure is internal. You don't even see the failure plane clearly. Even if you see the failure plane clearly, you won't be able to measure the angle because it's not possible. It could be even zigzag. So here, the only way we can do is by drawing at least 2 more circles like this. Forget about this radius and 2 theta. Let us draw 2 more circles and then take a straight edge to draw a common failure envelope. Let me take a straight edge. I will take a minute to get a straight edge. So, after drawing 2 circles, you can take a straight edge to draw this envelope to get C and phi prime. That's what we do. That's one way. The other way is to use this equation with known values of sigma 1 prime and sigma 3 prime to solve for C prime and phi prime. Let me give you an example. Let us say we have sigma 3 prime, 2 tests are conducted with 1 and 2. Here sigma 3 prime is 15 psi and sigma 1 prime is 70 psi, and in the second test sigma 3 prime is 30 psi and sigma 1 prime is 115 psi. So what you can do is draw a sigma 3 prime, sigma 1 prime, tau prime, and 0, 15 to 70, one circle, and 30 to 115, another circle, and then take this straight edge and draw the Mohr Coulomb failure envelope like this. Let me draw the Mohr Coulomb failure envelope. just touches the two circles, so that is the failure point, and measure its slope angle as phi prime. You can also extend this and draw that, and this is C prime. For this you need a graph paper, and you need a compass to draw the more circles. You set these points. This is 15 and 70. That means the center is 85 divided by 2. That means 42.5. Once you put the center 42.5, you take the compass to draw this more circle. And for these two things, this being 30, this being 115, this is 145 the total, so the half of it is 72.5. From 72.5 you need to draw this more circle, and you need a straight edge to draw the common tangent, and you can get that. This is the graphical method with graph paper, compass, and you need the protractor to measure this angle. So that's easy if you can do that. The other is analytical method. That means two unknowns, two equations, simultaneous equations, we may call, that means we are trying to get C prime and phi prime with the data we have, making use of this equation 2 times. Using equation 10(9) 2 times, we can write that 70 psi equals 15 psi times tan square 45 degree plus half phi prime over 2 plus 2c prime tan 45 degree plus half phi prime. And we can also say from this second set of data, this 30 psi equals, not 30, I'm sorry, 30 comes later. 115 psi is 30 psi tan square 45 degree plus half phi prime plus 2c prime tan 45 degree plus half phi prime. Solving these two equations is not as difficult as you think if you can substitute x for this tan 45 degree plus half phi prime and y for 2c prime. So what I would say is that you can eliminate psi. C also has psi, so cohesion has the units of psi, everything in psi. In this case, psi, this is psi. So this, you can say that this is 70 equals 15 x square plus 2 this yx by replacing for 2c y, and this entire thing is x. That means if tan 45 degree plus half phi prime is x, this tan square is x square, so there is no y here, 15x square, and 2c is taken as y, so yx. So this becomes equation 1, and here in the same way you can write this 115 psi equals 30 times x square plus yx. This becomes equation 2. What we can do is write this equation 2 in terms of x. So that's easy. Take this 30x squared to this side, 115 minus 30x squared is yx, and then bring back just x to this side to get y. That means we can write 115 minus 30x squared divided by x equals y. So after getting y, we can substitute in this. When we substitute in this one, actually the simplification becomes quite easy. If you understand this step, I can erase this one and substitute it there, which is easy. So let me erase this one, and I will substitute this y value here, and let us see how easy it is. So here 70 equals 15x squared plus 115 minus 30x squared divided by x times x. I think you agree with me on that. I wrote it down exactly, and just replaced y with the value we have got here. So I can erase this one and then see how easily we can simplify. Simplifying means here x is gone, eliminated. So this can be simplified as 15 x squared plus 115 minus 30 x squared. That means this is simply 70 is 15 x squared minus 30 x squared. That means minus 15 x squared. 115 minus 15 x squared from this. If you are okay with that, so that means this 70 minus 115 is minus 15 x squared. I think you agree with me on that step. I took 115 to the side. So this is minus 45 is minus 15 x squared. That means 45 is 15 x squared, or x is from this we can say that x is 45 divided by 15. X squared is 45 divided by 15, that is 3. That gives x equals square root of 3. And at this stage, let us equate it with tan 45 degree plus half phi prime. That means we can use the calculator to get what 45 degree plus half phi prime is, and then we can calculate 45 degree, let us say 45 degree plus half phi prime is tan inverse square root of 3. Let me use my calculator. Let us see what that is. tan inverse of 3 to the power of 0.5 gives me 60 degrees. This gives me 60 degrees. That means from this we can calculate 45 degree plus phi prime over 2 is 60 degrees. You can rearrange and get phi prime as 60 degree minus 30 degree time 60 degree minus 45 degree. Let me erase that. 60 degree minus 45 degree times 2 gives 30 degrees. That means the slope angle, whether we draw on a graph paper or do this calculation, should be 30 degrees. But in a graphical method, we may not be getting exactly 30, we may be getting 29 or 31, because this cannot give very accurate results. This gives very accurate results. Once we have this, we can substitute for what we assumed as in this equation to get the y value. The x value is square root of 3. Let us substitute square root of 3 here and see what we will get. I will erase this. You can go back and watch this video, but here let me substitute square root of 3 in this equation for x. Here, as we got here, using x squared equals 3 and x equals square root of 3, this becomes 70 is 15 times 3 plus y times square root of 3. Let us get y value from this. 70 minus 15 times 3 divided by square root of 3, and let us then equate it to 2c prime to get effective cohesion c prime. So here this is 70 minus 45 is let us calculate that one. 70 minus 45 is 25. 25 divided by square root of 3. I'm getting this as 14.43. 14.43. That means 14.43 psi divided by 2, which is 7.215 psi is the effective cohesion. I will continue this chapter in the next video. Thank you.